All right, let's keep going with our notes on Newton's laws. I'm now in the second packet, and that would be page 22. So now, first of all, I'm reminding you that the book uses W to represent the weight, the weight vector, but I prefer to use F sub g, the force of gravity, but it means the same thing. Another little technical point, um, the book defines a vector called g with a vector sign above it to be the acceleration of gravity, and so this g has the negative sign, the downward direction built into it. So you don't need to put minus g like we did before because it's already built into the vector g. This had me confused for a while too. Okay, but for example, we would before we were saying that f sub g equals minus mg, but that's before we had the vector version of g here. So now that we have this vector g, we can write f equals m times vector g and not have to worry about the negative sign. And yeah, the book likes to use the x hat and y hat vectors, and I'm using the more common I hat and j hat vectors. And okay, so I'm going to say that. Okay, now what I want to do is go over this activity, but the problem is I don't have a scale here. I'm at home. I don't have all this equipment. So let me just sort of explain to you what this is about. So let's say that you had a mass, and okay, so you have this little mass here with a little hook on it, and you've got a spring scale. We in the lab we have these things that have a spring in them, and you when you pull down, the little pointer moves up and down, and this is called a spring scale. Okay, so let's follow the instructions here as best we can. So the first thing is I want to draw the free body diagrams for the forces on the mass and the forces acting on the spring scale. So let's do the mass first because it's easy, right? So this is going to be the mass, right? Call this m. And so there are two forces acting on it, right? There is gravity, which we'll label the F sub g vector, and there's the spring pulling up. And I don't know what we'll call it. Let maybe call it F spring or something like that. So okay, so that takes care of the mass. Now let's do the free body diagram for the spring. Now I'm going to draw a dot here. That's the spring. I know it doesn't look like it, but that's the spring. And you've got a downward pull from the mass, so call it F from the mass. Right? And then got something holding it up. Maybe this is, I don't know, your finger or something up here. You've got your finger. And so, so here's your hand, and then here's your finger holding it up. So we could call this F finger. Okay, so we've got the two free body diagrams. Okay, that's an easy case. Now, what if we had a slightly more complicated case. We had a spring scale, and then here, hooked onto it is another spring scale, and then hooked onto that is the mass. So the first question is, what do you think the two scales will be reading? So let's go back to the first one here where we get into the more complicated case. Let's suppose that this was, I don't know, let's say it's 0.1 kilograms for this mass. Well, in that case, the scale should be saying, okay, 0.1 times 9.8, 0.98 newtons, right? So if it's 1/10 of a kilogram, the scale should say 0.98, right? So what are these two going to be saying? What's this scale going to say? And this scale is going to say, here the mass is still 0.1 kilograms. All right, so what do you think? Would you agree with me that this one is going to say the same as before? It's going to say 0.98 kilograms. Yeah. Okay. And what's this one going to say? Yeah. Now, a lot of people make weird mistakes about this. Maybe it's going to say twice as much or half as much or whatever. Well, it turns out that it's going to say 0.98 plus maybe a little tiny bit, because these scales are light. They're, they weigh maybe a few grams. So it's going to say 0.98 plus a little bit, which is the little extra mass or weight of the lower scale. And so this scale, the top scale, is holding up the mass and the bottom scale. The bottom scale is holding up just the mass. Okay. Now, let's draw the free body diagram for this thing here. All right, so we want to draw the free body diagram for this scale. So there are going to be three of those. So the first free body diagram is going to be for the mass, m, and you have its weight, f sub g, and you're going to have the force holding, so the upper spring is holding up, the lower spring is holding up the mass. So we're going to have F lower spring holding it up. Okay. The second free body diagram, I'm running out of space, so maybe I'll use red. Okay, so we're now doing the free body diagram for this guy here. So we're doing this one. Okay, so here's my spring. We have the force of the mass pulling down on it, and I forgot this one here, and the force pulling up of the upper spring. Alright. And then let's do, I don't know, let's use blue maybe for this one. No, green. Alright, let's use green. Alright, so we're going to do this one now, the upper spring. So, okay, we have a dot for that one. And so what's pulling it down? Pulling down on it. Well, the lower spring is pulling down on it. So we have a downward force for the lower spring. Oops, spring. F lower spring. And then we have, okay, there's a finger holding this up. All right, an upper force which I'll label F finger. All right, whew. So we've got three body diagrams, free body diagrams. One for the upper spring, that's this one here. One for the lower spring, that's this one here, and one for the mass. Okay. So for 3 objects, you need 3 free body diagrams. Okay, now the last exercise here, basically what I'm asking you to do in this one is to set it up so that you have, I'll use them right, so you have a mass like this, and you've got, let's say, I'll draw a spring here that is holding it up, another spring here that is holding this up. And the question is, what are these two going to read, right? This is still 0.1 kilograms. So gravity is pulling down on it with 0.98 newtons. Now, if the two springs are equal in strength, what is each one going to do? And yeah, so I mean, maybe the answer is obvious to you, but maybe it's not. But anyway, to get the right answer, what you do is, I mean, one way to do this, draw a free body diagram. Free body diagram on this mass. Okay, so you've got gravity pulling down F sub g. And you've got, and I'm going to draw these half as long. And okay, well, actually, I want to make the left one here be blue. Let's make this one be blue. All right. Upward one. So F spring, the blue spring. And then here, let's go with the green one. All right, here we go. F for the green spring. And if you got this right, you want this vector plus this vector, the two spring vectors, to be, when you put them, end to end, they're going to be of the same length as the mass vector, because you want the total force on the object, on the mass, to be 0, because this is supposed to be equilibrium. Okay, well, once you've got to this point, right, if you've been drawing your free body diagrams like good students, at this point it becomes obvious. Yeah, the half of the weight is held up by one, and half the weight is held up by the other. And so that means this one here, what's half of 0.98, 0.49, this one should read 0.49 newtons, and then this one should read 0.49 newtons as well. Okay, so anyway, that's the story of this exercise. The next one is much more complicated. The next exercise, the idea is that you've got a mass. Okay, once again, here's your mass. And you've got a spring going like this at an angle, and it's holding it up. And you've got another identical spring, and it's going also at an angle and holding it up. And okay, now, and let's say this is still 0.1 kilograms. So I'll go back to it, 0.1 kilograms. So gravity is pulling down with 0.98 newtons, but how much pull do these springs have to have? And to figure this out, it becomes a trigonometry problem, actually, because what happens is that you want to have the vector, the force vector of this spring combined with the force vector of that spring this plus this, it should be the negative of 0.98. And so what you're going to have to do is, first of all, break this into horizontal and vertical components. So here's a vertical component and a horizontal component, and then over here a vertical component and a horizontal component. And then you have to realize, ooh, this one and this one, they're going to cancel. So what's going to happen is, this vector and that vector cancel. And so all you're left with is this one here. But there's a relationship between the length of this vector and the length of that one. It's going to be the cosine of this angle, which is 45 degrees, times the hypotenuse gives me this one. And so by working your way through this trigonometry, you can figure out what the springs are going to read. And I can tell you that it's going to be, this one's going to read, it's going to be 0.98 divided by 2, because the divide by 2 is because this one, and there are two springs, each one's doing half the work, half the pulling upward, times 1 over the cosine of the 45 degrees. 45 degrees. Okay. Now, we can't, unfortunately, under the circumstances, you're going to have to work on this yourself, okay? This would make a really good exam problem, a good quiz problem. So I strongly urge you to figure this out. If you have trouble, that's what office hours is for, and we will be having office hours. Okay, this problem here is very similar to the one we just were talking about. So you go ahead, you study this. I expect you to be able to do this type of problem. Okay, and let's see, another one here. I need you to look at example 5-6 in the textbook on page 129. This is one of my favorite quiz questions. So, word to the wise, study it. Okay. So, I think it's time to stop and upload this video. Are you having fun? I'm having lots of fun. Yeah.